A few months ago, I reconditioned a collet chuck for my Colchester Student lathe, and the collet chuck came with just 3 collets. So I've been on the lookout for a whole set. So I recently saw this set available online, and I took the plunge, and I think it's quite a good set actually. Now, the difference between the old ones and the new ones, the jaws are hidden behind this plate. So it's about 5 or 6 millimeters back from the front. So you can't actually grip the work right up to the edge that you're working on, whereas these new ones you can. Now I understand that they're interchangeable. This taper is the same, but there's one feature that is slightly different. The ring, the adjusting ring that comes on the front, has a smaller hole for the older collets, and the difference is around about 0.3 of an inch. So that hole needs to be larger. Now I've looked around briefly online for rings like this, and I haven't seen any available. And a friend of mine said that you can open these out and you can use the same adjusting ring with both sets of collets. And I've checked the internal diameter here, the face, and indeed it does seem that there is plenty of margin there. Now I've been cleaning the collets up, and of course you can never really tell. There's one or two that have been well used and others that don't appear to have been used at all. So in overall terms, I'm very happy with this, and I think the 2 sets together will suffice for everything that I need. So the challenge is going to be machining this ring. Now I've had a go at this with a file just to test, and it is hard. So I purchased this boring bar, and I'm going to give it a go and see if we can open this ring out. If I fail with this, I'm going to have to find another way of doing this. I really don't want to mess this up, so I'm going to go cautiously. I'm planning to hold the cap in the 4-jaw chuck, but before I go any further, I'm going to just make some jaw protectors from aluminium sheet. I've made one already, so I've got a pattern. I'm just going to make the other 3. This has been something I've been meaning to do for a long time. I thought I would just take an hour or so out to do this. This will certainly make setting up a lot easier. They're not the most elegant of chuck jaw covers, but they work. Yeah, I didn't do that very well, did I? That should have come over the top a bit more to hold it in place. Next time I make these tangs need to be longer so that they actually grip more around the outside there. I suppose in the meantime I could just put a bit of spring in there to hold it in place. I'm going to consider these Mark 1. Next time I will put a bit more thought into the shape of them. Okay, let's see if this tool will touch this hard material. Well, it seems to cut it, but I've got to get the right feeds and speeds, I reckon. Well, it looks like there's a hope of cutting it, but how long that tool's going to last, I don't know. Now, before going any further with this rather precious end cap, boring it out to the new size, I wanted to double check that these two types of collet are truly interchangeable in here. So I took measurements of the critical dimensions of the two collets, especially the profile of the fingers in relation to the center line and this front face, both on the old style and the new style. So these collets are both 1 1/8 to 1 1/4 capacity, so they're equivalent. So what I was aiming to do was to show that when these are located in the body, what angle the fingers have at the outer edge and where the fingers come in relation to the face. That requires a little bit of manipulation on the CAD drawing, because these actually change angle as they go into the body. But I was able to move them inwards until they touched the work, so an imaginary bar in there, and then from that I was able to measure this outer angle on both the old collet and the new collet. And the old one to the outside was 12.6 degrees, that's in other words the half angle of the taper, and for the new one that came out as 12.63 degrees, which I thought was remarkably close considering how I had to take the measurements. The way that the collets sat in the body and their relation to the cap which comes on the end here indicated to me that almost certainly these two styles of collet are interchangeable. Now the drawing showed that there was a slight offset of about 0.14 of an inch, but I'm quite sure that will be taken up in the thread, and I think there's enough capacity there to ensure that they operate. So it seems to me that these were designed to be interchangeable. So that's a great encouragement. Now I can go back to the lathe and continue boring out that cap. So you can see here, I hope, that that insert has taken quite a hammering just with a couple of cuts. I'd actually turned it around and given it 2 goes. That's taken the corner right off it. Now I don't know whether that's due to the grade of steel I'm cutting, or my feeds and speeds, or whether it's the quality of the insert. I have no idea. This is kind of a new area to me, cutting these kinds of materials. So I'm trying another insert. I'm going to put this one in now and give this a go and experiment further. I also noticed there was quite a lot of push on that bar. In fact, I could see it moving away from the work, so there's no need to have it sticking out that far. So we'll bring it back and just reduce the overhang. Well, that seems more successful. Yeah, I'm going to stop here and we'll continue this tomorrow, but I think we're on the way now. As I mentioned before, carbide inserts are a new thing for me really on the lathe, so I'm experimenting here, but this new carbide insert seems to be holding up very well. It looks like I'm going to be able to finish the job with it. So at the moment I'm using a feed rate of 6 thou per revolution, that's about 0.15 millimeters per revolution, with a cutting speed of about 260 feet per minute, or 1.3 meters per second, 78 meters per minute. I don't know if that's about right. It looks about right to me. It feels about right. There's a lot of noise which picks up on the microphone because it squeals a lot. I've got just over 0.5 millimeter left, plus a bit for clearance. Yeah, that's good. I want to leave a bit of clearance in there, so that's looks about right to me. Inevitably there's a burr on the inside there, so I need to find a way to remove that. That's going to be really important because that face, that mating face on the inside is critical. Okay, the ring has come out quite nicely. I've got just a small chamfer in there and a chamfer on the reverse side there, very small. Now this isn't ideal. In the original design, this land was separated from the inner diameter, and the inner diameter was slightly recessed, and I believe that was there to prevent damage on the corner. Anyway, I would just have to be careful. It's the outside that is going to provide the majority of the alignment, and the squareness of that face is really important. So it's a nice smooth fit in there, and I was very careful to make sure that I'd removed all the burrs. Now the other comment I'd make is that actually I put this back in the lathe and rebored it slightly bigger because I discovered that the diameter of this land here was a little different on different collets, and unfortunately I made it originally to one of the smaller diameters. So I've made sure that all the collets can fit in there with just a little bit of clearance. What we want to do is to ensure that the collet is seating on the taper and this end face, and the body itself should be able to float. So if that ring is constraining things, then it's less than ideal. Now you could argue that actually it doesn't really matter because the body can float. Just for the sake of ensuring that we had the best possible setup, I wanted to make sure there was a definite clearance there. Now I've done some run out tests before anybody points out that the way I've done this is less than ideal, because I've used these sections of steel stock which I have in the workshop. Let me just point out that I can't possibly use ground test bars for all 11 collets. It's just going to cost too much money. So I've gone more for a statistical analysis of the results, bearing in mind the limitations of the materials I've used. So the largest diameter I used was bright drawn mild steel, a clean section. Again, I know it's not ground, but I put that into the test results just as a comparison. That's because it's one of the larger diameters, 1 1/4. And then I used a section of silver steel. Although this is ground, I know it's only centerless ground, and we cannot guarantee its straightness. But I put that into the test, and that was a metric size, so it's 0.53 inches. And then another piece of silver steel, this is 0.406, and then a smaller, which didn't turn out very well because that could well be bent. I also used this piece of EN8 1 inch, and I put that into the test, and a homemade test bar which I had made for another job, and that's just under 1 inch, but that is straight. Because of the test bars and the fact that they are not reliable, I've had to go for statistical analysis. So I'm looking at the overall trends. I don't mean statistical in a strict mathematical sense, I mean just in a workshop sense. Now this is my setup here. So here is the taper, the nose taper. Here is the body of the chuck, the collet chuck. Here's the workpiece. I measured the run out just adjacent to the face of the collet chuck and 5 inches away in most cases, or in almost all cases. And I tabulated the results, but I also took a note of the angular position of the maximum run out, with 0 corresponding with the keyway on the nose taper and going clockwise. And the results came out like this. Now I don't expect you to look at the details, but just to show you that I've taken quite a few measurements. And some of the results I could remove, particularly this one, because I think the bar wasn't straight, so I removed that one. And I've looked at the results in terms of run out here, and also angular position. and there are some conclusions that I can come to. So the first thing I noticed was that usually the run out was occurring close to 0 or 360 degrees, so close to the position of the keyway, or opposite, depending on how you look at it. So, maximum deflection closest to the keyway, minimum opposite, 180 degrees apart. And that's quite interesting. So you can see here that for the bright drawn mild steel, 1 1/4 inch diameter, that was occurring at about 210 degrees. Here the 0.406 silver steel was at 0 degrees. The 0.53 to 70 degrees, 0.53 again in a different collet. That was 330, and then 350. So, and over here 330. So, I mean, just looking at this, I get the feel that most of the run out is happening in the plane of the key. So that's interesting. I took the collet chuck apart and put the body back into the lathe to repeat a test which I had undertaken in one of my previous videos on renovating this collet chuck. And there's a link up here if you'd like to see that. So in that I noticed that there was some run out, and it was about 5/10 on the outer edge here on the bore that the tapered sleeve slides in. So that should be a reliable surface. That is a critical surface. And the interesting thing that I discovered was that the maximum run out occurred at 0 degrees. So in other words, it was correlating with some of the results I'd seen on here. So in other words, when that keyway is at the top, we were seeing the maximum deflection here and here. So that got me thinking about the nose taper, and I had dressed it up before, and I just wondered if now that I have not just the visual aspect of the nose taper and its condition, and I can check that by bluing the inner surface of this, the taper, but I can also correlate that with these results which I'm seeing, these statistical results. And I'm going to see if the damage on the nose taper in any way could explain this being canted up when this is at 0 degrees, in other words with the keyway at the top. So the nose taper on my collet chuck is the best female nose taper I have of any of my fittings. So what I've been doing is bluing this up. This is an area that's been dressed before I got hold of it, but the rest of it's clean. And I have been using this by bluing it up and then putting it on the nose taper and seeing where the high spots are. So I've blued this up again. I've done this several times actually, and the other thing is I've removed the key so that I can rotate and get a good bedding check. And I might just tighten that up as well. Now these fine measurements with my equipment are extremely difficult to undertake, but the interesting thing to me is that when I started this I was getting 5/10 of a thou, and then it dropped to less than 5/10, and now I would say we're less again. We're not half of 5/10, but we are definitely improving. Now the other thing that I want to look out for is the position of the maximum upward deflection, which is there. So it's still close to, it's around about sort of 10 or 20 degrees. That's still close to the plane of the keyway. So it's consistent. The run out is always in the same position. So I produced this little sketch of what I think is happening. This is the nose with the position of the keyway at the top, and this is a test bar, or if you like, the body of the collet chuck, and you can see it's deflected upwards a small amount, and that indicates to me that there is excess material on the top of the taper at the front or at the bottom at the rear. As I do the bluing and I stone the surfaces, I'm paying particular attention to these two regions with the keyway in the vertical position, and that does seem to be resulting in some benefit. Now, of course, this is all assuming that my collet chuck is true, and I think it is, and certainly this is the most critical piece of equipment. It doesn't matter so much if my 4-jaw chuck is out or my faceplate even, certainly not my 3-jaw chuck, but this one I'd like to run true. So I'm going to continue with this and see if we can make further progress. Okay, that's where I've got to. Now I know that I started off by checking the bore, but I thought I'd also just check on the outside, and there's very minimal movement there. Let's just do it under power because sometimes you get a slightly different result. You can see the needle is moving, so we really are contacting with the work, but it's minuscule. Just try up here as well. Yeah. So you see the needle is moving, but it's a minuscule amount. And finally we'll try in the bore. So in the bore there, we're now picking up, as far as I can tell, around about 1/4 thou. Certainly better than it was. So I think I'm going to stop there. I don't think I'm going to get much better than that. So I'm reassured that my nose taper is good, despite appearances. And I think what we'll do now is reassemble the collet chuck and put some collets in and do some further tests. Okay, I'm going to start with the 1 1/4 inch bar. This collet is 1 1/8 to 1 1/4, and it looks like it's not had a hard life. I can't see any damage on it, any dings or any marks. So if this has been used, it's been used very little. So we'll start with this one, of course making sure everything is clean, and I've gone through and lubricated everything. So we'll start with this collet and see how we get on. Now this is bright drawn mild steel, so when it's not going to be round, but I haven't got anything ground in this size, so we'll just include this for reference. Okay, difficult to tell really. I mean, clearly the bar's not round, but the total run out is about 5/10. As we move up the bar, away from the headstock, looks to be about the same. Okay, the next test piece is this bit of ground silver steel, 0.53, and I've got this collet here. Now this one you can see has got some marks on it, so it has been used. I will give this a try. So I'm having to wind this down quite a way. Probably there's enough capacity in the 1/2 inch collet, so I might just try that as well for comparison. In other words, the next size down. That would be, let me see, 3/8 to 1/2 inch, so we could try that afterwards, I think. Okay, that's not so good. So about 1.5 thou total run out. Let's just release the collet and put it back in again. Okay, we've got 1 thou total run out there. And as we move away from the chuck, that goes up to 2.5 thou, but who knows whether that silver steel is straight. So I've removed the 1/2 inch to 5/8 collet and replaced it with a 3/8 to 1/2 inch collet, and it's just got enough range to get that bar in. So with the next size collet down, we're getting about the same, about 1 thou, but to be honest with you, the surface finish isn't good on that silver steel, and it's got a click on there, so yeah, maybe it's less than 1 thou. And finally, with the same collet in, I'm going to try the 0.406, so just over 3/8. Okay, that's showing 1/2 thou total run out. And as we move away from the headstock, a lot more, but who knows whether that silver steel is straight. Okay, I thought I would dismantle the chuck again and rotate the inner cone back to its original position. If you look back at one of my previous videos, I milled a new slot in there. So I've returned the cone to its original angular position, and I repeated the results, and they're a little bit better. I put the 0.53 inch diameter silver steel bar back in the 3/8 to 1/2 inch collet, and we're definitely getting a better result now. That's about 1/2 thou, if not slightly less. Seems to depend on how you rotate the work. Yeah, it does. Back to 1/2 thou. And just for comparison, I'm now back with the 1.25 inch bright mild steel in the larger collet. So it looks like we've achieved about 1/2 thou run out at the face of the chuck, going up to around about 1 thou 4 or 5 inches away. A bit difficult to tell really because the bar is not truly round. Well, I think that brings this video to a conclusion. Of course, this hasn't been done perfectly. I haven't used ground test bars, as I've stressed throughout through this video, but nevertheless, it's given me an idea of the limitations of this collet chuck, and I think it's going to be adequate for what I need. So I'm very happy now to have a full set of collets that I can use with my collet chuck. Hopefully there's been something of interest to you here, particularly if you're interested in modifying the older style collet chuck to receive the newer collets. Thank you for your comments. Do keep them coming. I learn a lot from them. Hope to see you next video.